Okay, so yeah, let's look at the 4.1 loop, right? Let's go into details, example of loop. So we want to write a program to find factorial of n numbers, and instruction asks you to use while loop. So first, if we want to look at the logic first, so let's simplify it using pseudocode. How would you do that?
How to do it, Professor?
Read n, and pretty much just like 4, factorial of 4, right? After you read n, what do you do?
Find factorial of n. After you multiply n by n minus 2 n minus
While
3, ...
n is greater than 1.
Greater than 1, yeah.
And then
do
and multiply
n times
n by every descending number until 1, or
multiplied by n
or something like that.
Times n minus 1.
times n minus 2.
So I'm thinking about if n is 1,
and then ...
then we'll never get in here, which is good, right? Because we don't want to do 0, right? N times n minus 1. After we get a product, where do we store it? Like we get, let's say 2 factorial, 2 times 1, we get 2, where we need to store that, right? So where do we store it?
Where?
So we should store it into like factorial. Maybe in that case we should say factorial times.
Oh yeah, that
Well,
one.
we gonna miss the n part. We need to get the n itself too, right?
Yeah.
Which then mean we should do just times n. And then we can do the next loop. It's gonna be n minus minus, right? When n minus minus is just go back, so it's pretty much just n times the n minus 1 itself every time, correct?
Yes.
Is that right? Phong, you agree with me? You said you not understand. You agree with this or not?
What's the factorial?
Huh?
What's the factorial?
Oh, it's just a variable. We just initialize, like we have to end it. Factorial equals to 1, right? Identity, right, of multiplication. Like we have factorial of 2, pretty much just n is 2 times 1, right, equals to 2, right? And then 2 minus minus becomes 1. There's no longer 1 not greater than 1 is returned, right? So it's going to return, pretty much we just print factorial, which is 2, right? Now let's try with 0 fact. 0 fact is supposed to give you 1. So yeah, 0 is not greater than 1, then returns 1 right away. So that's it. Is that right, Phong? Phong, right? Phong?
Yeah. Can you try like 4? If n equals to 4.
Yeah, we can try. Now we're gonna write a program and try. Then we see the result. So I'm gonna write this on the Android, okay? Like last time I showed you, right? I show you how to use Android already. Yes. Yes. So I should be able to. Let's look at the layout again, right? On Android we have so we have source, we have RES, where the layout for the user interface, right, is. So now, this one, pretty much, I'm going to expand this. I call this as the math apps, like an application to get this math, like factorial button. I'm going to add a button named factorial, and this is a part it's going to display, right? So this is just the text field. It's going to display the result. So just like the calculator that instead of hello world, I may just give the initial values to 0. Like in the calculator when it starts, it's like 0, right? So you could change the value on the XML file itself. This XML file pretty much just mapping to that UI. Same thing, or you can just change on the UI one. Now I'm going to add another button. We will talk about this button first. So this button I'm going to name, like currently I have button that print out the first 100 odd numbers, button that print out the diamond shape. I'm going to have another button that print the factorial. So I'm going to call factorial button. So I give the ID to it, right? And the label for it is going to be factorial. Now the layout. So we have to fix the text. Text matches the display like that. First 100 odd numbers. Right, this is going to be factorial. ID pretty much is the object name, the button name. And now for the layout, if I wanted to show like underneath the number 0, what I need to do is have to control so what I'm going to do is already underneath number 0 because it's a constraint top to the bottom of display. This is 0 is the display. ID is display. Here, right? And the left and right parentheses means centered. So what we need to move is move these first 100 odd numbers down, right? So if you want to do that, so let's not doing that then. Let's put it underneath the diamond button, then you understand. So what we need to do is constant top to bottom of the diamond instead, which is the diamond itself. I need to give the, yeah, this is the ID of the diamond. So I just need to replace it. Now factorial button just go underneath of the diamond, right? Constant top, that means top of this object, which is at the top to the bottom of the diamond, right? Alright, so that's done with the how you add the button for that. Now let's talk about how to code this now. So technically, don't worry about the button yet. Okay, So this code, I make the code for each button, right? This is the first 100 odd numbers button. This is to print out the diamond shape button. Right, so first, like I said, don't worry about the button yet. Just worry about how to display. And we have the text name display, right? That is just like where you do an output to. So let's talk about how to display first. So I'm going to say display pretty much technically equals to technically display is going to be an object, right? We have to set a text. Set text equals to the output, right? Which is, I just create an output as a string. Okay, and we were talking about array a little bit, right? A group of string, right? In the bracket, and initialize them to a blank value, right? So let me simplify this first to be string out before we talk about even in array. So if I said you are late, if I just say that, right? This is an example. So I set the text, right? So this is an emulator. If I don't want to connect to a phone, I can connect to emulator. I just click it and hit OK. Okay. So let's look something. We say no result found that matches the given name at layout constraint top to bottom of diamond button. So there's an error here. So technically, let me move this down then. Because the order, this one happened to declare first, right? If I move this first, it doesn't see it. So let's rerun this. Let me try this one, the second emulator. Okay. Your GPU driver information. Some users have experienced emulator stability issues with its driver version. As a result, we are selecting a compatibility renderer. Please check with your manufacturer to see if there's an update driver. Okay. It's just warning. Alright, so this is like if you don't have a Samsung or Android phone, you can just use emulator to run this. Alright, so we are waiting for this to load up. It's installing APK, launching the apps on here. There you go. Hello, purple shirt, you're late.
Hello, purple shirt, you're late.
Right.
Damn, the professor just called you out in code.
How computers signed each other right
So we
come to work one day, so
it's very simple, right? This is just like hello world, like you do system.out.print. But we just do display.setText.out. Okay? I just want you to focus on these two lines, that's it. The rest is not right. We just links to the display from this line, right? From the ID that we look at the layout. Now, I want to display the factorial, right? So let's bring the logic into this code, right?
X recorded.
So we need to initialize factorial equals to 1. So what I'm going to do, I'm going to initialize that. So in it, let's say integer, right? Factorial equals to 1. Okay? Now, what's next? Read n. So in this case, if I want to read input n, I could do, right? Through the text. If I have the text field. So let's add the text field. But before we go to that, I'm going to declare, let's make it simple first. Int n equals to, let's test with factorial of 4, right? I just skip 4, but next time I'm going to get the text to replace the 4, right? Now, I got an n. I just assume to 4 for now, but we'll fix the code to read n. So I want to do a loop while n greater than 1 do, right? So we initialize n, we create a loop. Let me move this up. While n greater than 1, right? What do we do? Just like the logic that we just start out. Very simple, right? Factorial equals to factorial times n and decrement it. Okay. What's next? We just display out. Who's going to display this guy? Display the set text. So we need to set out to, instead of out, it's going to be factorial, right? That's it. Now we just rerun this and see if it's going to find, what's factorial 4, guys?
24.
Let's see if it's going to show at 24. Oh, so it say, let's see what happens. It doesn't show, meaning that I'm looking to see if there's an error. So let me rerun this. Let me use another one, Nexus. It's creating 2 different emulator now. This is Nexus. This is Pixel. You can have multiple emulators to test how it look on different phones, right? Or tablets.
Here.
Alright, so it looks like the application having problems. So it looks like there's an error in the code. Out equals to factorial. because factorial is an integer,
Yeah.
so string dot, we have to test on this one, right? Change integer to string, right? Dot value of, right?
Yes.
Let's test that. I was expecting to see error message. Okay, that's probably why, right? Because you try to set text to an integer, that's why there's an error. It will not allow you to do, right? So I have to convert the integer to string first. So we get 24. Alright, now I didn't deal with the button yet, right? Which I supposed to click this and show the first 100 odd numbers. When I click this, it's supposed to show factorial. But this program doesn't do that yet. Why? Let's read the code for the first 100. First 100 odd numbers pretty much just do the same, loop through it, right? And increment every 2 and set the text inside. So this is the logic for that. But it will do it when I click the button. See that? Just like instead of let it display factorial right away from this code, right? Starting from here, right? I could technically make this as a method. Like this one, I didn't make anything as a method. Okay, let's not talk about that yet. I could technically surrounding this whole thing with factorial button, right? Just like this guy, I surround with the factorial button and set on click listener. Okay, so this is pretty much a syntax that you just need to memorize at this point. In 201, you learn more about why I have to do this. Like, remember, I was teaching you about lambda. This is just like the lambda in JavaFX, right? So what you want to do is be able to link to the button. So we have to create a button. And the button name is factorial button, which is we created on the view, right? The layout. So we can find view by ID r.id dot factorial button. So that's pretty much linked to the factorial button, this guy here that I named factorial button like there. See that? I link it to my code right there. So we're able to connect to that into my code, right? So in this case, we can start to surround this content for the factorial, right? With the factorial button dot set on click listener new. Like I said, this is just pretty much remember that we talk about the object should have a click. When I click, it should listen to the action on click, right? View dot on click listener. I do alt enter. It's going to implement the on click method for you. And then you move this code inside. When I click, it's going to do factorial. That makes sense? It's just like you surrounding with the if statement, make it to be true when you click, all right? And then you do this statement. If it's not click, it's not going to do it. Make sense? So now, the problem now is the out. That's the scope of the variables. Like, remember, the variable should be valid only between the curly braces, right? Like out is actually outside. See that? So it say I don't know what's the out. Out is right. Variable out is accessed from with it inner class need to be declared final. So this is called inner class. The things that we see here because we create a new class named view. If we look at this is called inner class. Okay. So that's why the scope will not be able to reach this. Like I have another class named main activity and I have another inner class named view, right? Technically, they want you to modify this to be final, which is I did create name output here, final. Like if you pretty much declare final, the same thing, it will work, right? It will be able to access. But it wants you to transform it into one element array, meaning that it wants you to change it to an array like that. And when you declare an array, you just need to put curly braces like that. That's what it wants you to do. Then when you're dealing with array, you have to put the brackets like that, right? At index 0, that one element array. Make sense? That's what it means, right? So now if I run this, on my emulator, it should be able to work with the button. Let's try again. Okay, we hit factorial. See that? We hit 500 odd numbers, 5 factorial, right? Or print the diamond shapes. All right. Now we want to change the input instead of always solid coded as 4, right? Hard coded in there. So we can take the value from the user now. Pretty much just make a calculator to 5 factorial, right? So we're going to need to redesign this a little bit by making user be able to use the text field here, right? So put it right there. So text is going to show 0. Okay, just like the calculator, right? Now let's see if we can align to set it align to the right. So let me see if I can set a property. So I'm looking for a property that can align this to right, just like a calculator. So this is called edit text, right? So you can set the gravity to right. So this technically is setting the code. Or you can do, if I set in the XML with that, let's try this one. So we use gravity. I was looking, here you go. This is the gravity. We can make it to the right. Does it do it? gravity. Center, it is center, right? Right. So we made it to right now. Now we can make this bigger. Let's put a set of font size. I'm looking for we can change the style.
Look at how much things I was
We can change the size right there.
I got links every day.
Let me make it maybe way a lot bigger than that.
It was one of the biggest companies in the
Okay.
dude, I had a temporary clearance and everything. This company, top 10. This is a software management company. I used to. No, I was
Okay.
like information systems type of not software.
All right. Wonder if we can put a border, background,
And I looked for another article. Which one is that? Look at the letter of recommendation.
color, like that. Okay. So now let's just run this to see if we can actually enter the text through this. So I could enter, right? Maybe I should make the layout. So this is the one where I edit text. Wrap content. I should make it wrap content, so it's gonna fill out the width. Okay, like fill out like that. All right, so this is just the height. Okay, 60 pixels. Now, what I try to do is when I click on this, I just like to make it like maybe clear it. Like now I click, it's not clear, right? Or yeah, then like now I have to manually clear it, right? So that means it has to add some clear, like I'm sure that you have to edit text, right? On click. So you have to pretty much just add the listener again. Like just like on click, you set text to empty. Just like the way that we do click the button. Make sense? So we have to do something like this. Okay, so to edit text. On click, now let's say on click, let's think about where should the method on click belongs to. So this whole thing pretty much just made a class to implement on click listener.
It's from the CEO.
So it's just try to put into the main activity. That's what it means. Like when you launch the program. That's what it means. Okay. All right. So let's see. What I'm going to do, I'm going to move this down. So we have background, text size, and so on, right? Now I'm not sure why this have the error. Let's check out. This missing constraints. So they talk about the constraint layout that we didn't have, like the layout like that. It's missing. To layout. So yeah, because we put it into the constraint layout, and it's missing the constraint. Like this is a constraint layout. So what I'm gonna do, let me try to make it to left and right of the parent. It's just going to center it like that. Okay. All right, so I just make it ignore the missing constraints. All right, so now go back to the code now. We finished the layout. We try to read that in here, right? So we need to know ID. So did we give the ID? The ID is edit text, right? So meaning that same thing. I need to declare edit text here, right? And name edit text equals to new. No, equals to, it's not a new. It's pretty much just deleted from the XML file that we just created. ID, what's the ID name here, guys? Edit text, right? So we just link to that edit text. Now we should be able to read the values and replace that in, correct?
Okay.
Make sense?
That's what you,
So what I'm going to do, I'm going to say string input equals to edit text dot get text, right? So let's see, it's going to return get
Professor Hamid. Does it work now?
text. So get text is actually return identical. So I have to change it to string. Alright, then I have it as input, right? Now this guy technically need to have input linked to that. Like you need to change it to where parsed, right? Integer, because it's an int dot parse int. You want to parse input. And this is the same thing. You have to add the final then you can have an access to it, right? Because of the scope, right, of the variables. All right, so like I said, this one is not clearing the text yet, but let's just test without clearing the text first. We can make it to clear later. All right, so now I just need to say factorial of 5. What's factorial of 5, guys?
So 96.
So the output is not correct, huh? So let me change to 4 and test again. It's still 1, so something not right around. Maybe we want to see what's the input that we get then. So we could use, normally we can do system.out.print, right? So we could use toast like pop-up dialog, right? Make text input. So let's see how to use toast here, right? Like pop-up dialog box, like the option pane dot show message dialog. So you have to show context, duration, how long it's going to show, char sequence text. Okay, let me show you an example of the toast. Like this is like the option pane dot, right? Toast is just like the option pane. Toast is like at the bottom like that.
So much harder to make apps. Jesus.
No, it's just like pop up, right?
I know, right? Like, imagine making like an app like.
Makes text. You see that? Context. Get application context. Hello toast. And text. Duration. Toast dot length short, right? And then dot show. Okay. So this is how you use toast. So we're going to what we try to do, we just try to use this to debug our program a little bit by, instead of showing text, we try to show what our input value, right? All right, so I'm gonna run this. I try to see input value 0. You see it's tossed up right there. Whenever it start, it input value to 0. So that's why factorial is 1. 0 fact is 1. Because it's already set the values that you input. Right, because when I do change 4, if you notice that when I click factorial, it's actually still have input as 0. It never changed my input. That's why it's 1. That makes sense? Action to read the text, like from where? From get text here, right? Must be inside where? Inside the code. Right? I should not have it outside the code. Now I don't need this anymore. I can just comment this out first. So the action input has to be in here, and the edit text pretty much just need to be final instead. Okay? So let's try again. Like now, I'm going to make 4 24. Right, so if I say 5, what's factorial of 5? 120. See that? So factorial of 6, 720. So we just create a simple application to 5 factorial, right? Any questions so far? But the main exercise is you need to know this logic to 5 factorial.
I only have a question about what's the logic for the Fibonacci sequence thing. I've just never heard of that before.
Alright, so we're done with factorial. Any question on factorial, Phong? We're good? Phong? Now, question is, I think the sum of the odd numbers, you should be able to be doing that, right? Like, I already print out the first 100 odd numbers. I have the application, the buttons. Let's look at that one. This is how you do 100 odd numbers. Instead of display the output, you can just display the sum, right? So let's talk about Fibonacci. Now, before we go there, let me clean up this code a little bit.
Yeah, let's do that.
So let's see if I can actually make a function or the method name find fact. Let me just call factorial right away. Factorial methods. Okay. I'm going to create a method. So let me just create right here at the bottom. So what did I do? This is the method name on create, right? I just add another method name factorial. And I just take the code I need and put in there. Okay. So now we're just looking for edit text, the out and display. So meaning is actually looking for this guy, right? Which I can technically make it available in the class level. Edit text out and display. So because the scope, we were talking about scope. Since I have it outside of the method, so it's not going to be able to see display, edit text, and out. So that's why I have to put it in the class level. Then it should be able to see them. See that? What I did is I just want to make this very short. Where I click, it's going to find factorial, and the method factorial is going to do the work that we already know it. Okay. So let's test if the application still works as expected. Nope. Actually, I try to see they should have. So it doesn't like the way that we move the code here. Let me not worry about that yet then. Let me put them all back first. I will come back and tackle this because we want to focus on Fibonacci first then. Let me make sure it's still working. Okay, so that's worked. Factorial is 1. Now we want to find Fibonacci. So let's talk about the algorithms again with pseudocode. So what's the Fibonacci? At like the Fibonacci number starting from 1, right? And the next one should be 1, and then 2. Just adding the previous 2, right? To get the next sequence. So 1, 2 is going to be 3, right? That's Fibonacci, right? And 3, 2, 3 plus 2 is going to be 5, and 8, and so on, right? Correct? How would you write a program to do that?
Wouldn't it be similar to doing the factorial, but doing it in a just like a different pattern, kind of? Just like the concept.
Similar, right? That's a loop. And what type of loop that the assignment asks you to use? Oh, it didn't ask you to use any type of loop, right?
Yeah.
It's open. It's use do while.
Yeah.
Technically, you have to use do while because this one loop while, and this is for. That means this one has to be do while, right? So, I mean, the concept now is hard of. The difficulty is coming from the logic, not the syntax, right? So let's write the algorithms. This is the logic, right? So we don't want to worry about syntax. We worry about the algorithms. We separate the concern, right? So we just use pseudocode to help or flowchart, right? So how do we do that? We said, okay, first number. So we can initialize. It's going to say init Fibonacci of the first n number, right? So if I put, let's say if I put, like in this case, how many number? 1, 2, 3, 4, 5, 6. Let's do 7. So it's going to be 13, right? So if I say, let's just say it n equal to 7. That means I want to have 7 numbers, 7 Fibonacci numbers. So the program first thing is initialize. It has to start from 1. And the second one is going to be. Why the second one is 1? Why?
0 plus 1.
That means it has to start from 0, isn't it? So let's see if a Fibonacci starts from 0.
It does not start from 0. It starts from 1.
0.
What?
Yeah, otherwise it will never have 1 right there. That's why. It has to be 0 plus 1, right?
Oh, okay.
So this should be 8 Fibonacci, right? In this case, right? So if we use the loop, it's going to be increment. Okay, so we initialize init I equal to 0. Do, right? Do what? What do we do? Do we do? We want to increment I and add I to the previous I. Technically, right? So we can pretty much just say int temp equals to I, and then we say I plus plus, and then we say pretty much the next number, right? Which is temp plus I. That's going to be the next sequence, right? And next. Right? That's the next number that you're going to display. So now, once we get that, we pretty much just need to initialize the sequence, the array, init output, which is an array. Correct? An array. So we start to put zero, 1, right? This is pretty much the next one, right? So we're going to have to say output. So we want to get a sequence and put them into an array, right? So
you were checking this in your pocket.
it has to be like this. Output I. Let's just do I first. This is going to be what? We don't want to increment yet. We want to increment. So now this guy is going to be 0, right? And technically we don't want to declare temp in here. We want to declare temp outside. Otherwise, temp pretty much just record the old values, right? But you want to record.
Yes,
When you want to record, you want to record.
we can just leave.
So first you put output. This is an array of output. If you look at that, and the array itself has an index. So the first index pretty much showing. This is an index, okay? Index 0. I'm talking about index, right? I equal to 0. Output 0. The value is 0, which is correct, right? And I record that values as temp, or let me call previous. Then you understand, right?
Okay.
Previous, and then I start to increment by I to index 1. All right, and I'm gonna say while what? While it depends on the n, right?
Yeah.
I less than n, right?
Yeah.
So it's gonna go back.
Okay.
It's gonna go back. Now, what we want to record, we actually want to record what? Previous plus I, right? So we need to initialize previous right here to be equals to 0, right? So now if you look at the first time, previous 0 plus 0, we get 0, right? At index 0, right?
Yeah.
Now next time we record 0, we increment I to 1. So it could be 0 plus 1, then we get 1, right? Next time we're going to do the previous now it becomes what? But we actually don't want to record I. We want to record the actual values, which is output I instead. Right? Because we adding the value, not adding the index. The value 1 plus 2. Right? So we want to record the values at that index. Make sense? So it's going to go back to the next loop. Let's see, let's look at next loop is index 2. Output 2 equals to previous is 1 plus, yeah, we don't want to plus I. We want to plus, we want to plus the previous 2, right? Correct? Because if you plus I, it's not going to work. We don't add the index. We add the actual values.
You know, I'm not gonna like comment on Megan Fox's acting career, but like, she's not look at this girl.
So let's start from the beginning again. Okay. So if I have 0, previous now equal to 0. Previous pretty much is the one before 0, right? Plus if I plus I is 0, it works. But it will work at this round. But it will never work where it get to secret like 2 or 3. Like 3 start to be not working because maybe 4. Let's look at index 4. Because this one depending on 2 plus 1, not I plus 1. Make sense? Not I plus 2, yeah. So we should be able to record like to the previous 2, right? Now I only record to only 1, right? So let's record to the previous 2. How do we record to the previous 2? It's pretty much just this guy. So let me call previous, like pretty much the one before previous, okay? So let me call, like this is previous, right? This is previous, okay? So at this point, I need to declare init previous. Let me just call previous, shorten it, like before previous, right? Previous. So, like for example, if I want to get to 1, this is called previous, and this is called previous, right? So previous equals to 0. Now the output should be previous is plus what? Previous, right? The previous 2, pretty much, right? Previous plus previous. And then I start to record, right? The one before. And I have to record previous 2, right? Correct? So previous at this point should be what? Output I minus 1.
And then would you, okay.
Now, the first time this could be an error. If we do that, because first time I is going to be 0, right? 0 is fine.
Professor,
But 0 minus 1 is going to get to index minus 1.
would you go 2 plus I minus 1 plus, and then do I plus 1? Plus I plus 1? Do you get what I'm trying to say?
1 second. So the I minus 1 here will only do when we have to do this. If I not equals to or I greater than equals to 0 or I greater than 0, we can only do this. Okay? Then it will prevent you from the error. Because when it's 1, it works. Alright, so that's pretty much the logic. So let's test that. Let's test that first. So what I'm going to do, I'm going to take this whole logic and put into our code. So we need to create the same thing like this with Fibonacci. So what I'm gonna do, I'm gonna do the same thing. I'm not gonna worry about the button yet. I'm just going to worry about the logic, how to do this. So technically, I'm going to copy this code and paste it over here. So I'm going to call int, right? Change the algorithms to Java code. Like now, just assume n equals to 8. Previous equals to 0. Previous equals to 0. And we technically have the output already. So yeah, let me just create another one for now. Out. Okay. Fibonacci. We don't need this anymore because I use previous instead of temp. We need an array. So this has to be an array. Now how do we create an array of string? We can just do new string. That's the keyword. And giving the size pretty much just the n, right? The size of your Fibonacci sequence, right? So we create an output of an array of 8, right? Name out. So we call out I. Do curly braces while I plus plus and end this with semicolon. If we do this, right? If I greater than 0, we do this. All right, now let's see what happened to the errors. Oh, this is string, so we want an array of integer because those are integers numbers, right? And when we display, we can just convert it later to string. Previous. So we talk about outs. We use outs now, right? I just changed the name to outs. Already. So now we want to display this. We already have display, right? We can just set the display to dot set text, right? To we need to get the contents of the arrays out. Call out, right? So they have arrays of 2 string. Array of 2 string will print the contents of the arrays out. All right, so let's run this. So I put the arrays out in there. So let's see if we get the sequence. All right, so it looks like this one only returns our zeros. So let me make sure. First thing is, let me make sure I want to see. I want to make sure to go to the contents of arrays by myself using for loop. Okay. Without using arrays dot to string.
So I have this
I want to make sure that first.
black hole, right? Gets
And also it always shows 0. Let's see if something always make it to be 0.
push is enough to shoot you so fast,
I,
and the energy's enough.
if I greater than 0, I plus plus.
Into a different dimension. We have
Oh yeah, it's always 0 because of this guy.
Do you get what I'm trying to say?
Let me just put this back.
It makes kind of sense, right?
Because it's always previous plus previous, it's always going to be 0, right? We have to change the value of previous.
So the black hole sucks it out,
Like this is always going to be 0.
spits it out.
You have questions?
That's
No, I mean,
So it's not like
if you use the
keep
if
separate thing. It's like
then you can just use the factorial formula,
but nobody knows where.
which is like the n times n minus 1.
So what happens?
And if not equals to 0,
The right
I mean, sorry, if equals to 0, then the answer is definitely 1.
You might lose.
So I don't use the
Any other universes?
to do for the n times n minus 1 and with them.
No, or it's just technically it's
Times is not adding. Fibonacci is adding, right?
we
It's
have
adding, but there's a
enough
formula
support
for
for
it.
it.
So
Oh, there's a formula for that already.
yeah, so the formula is like 5
But
times
we
4
have
times 3
we don't
times 2
have
times 1.
we don't have the technology
So you
to
want
yet
5 times
the
n
tech
minus
to
1.
yet.
So whatever the n initial value is,
So what I was thinking the other day,
there's a formula.
Fibonacci equations.
ago, right, 30 years
Yeah,
ago,
there is.
we had like who would have thought like this would exist, you know? Like look, it's a whole
Or you can
screen,
just
there's
take
everything,
factorial
you know?
formula.
Okay,
See how
so that
fast
should
technology
be another solution.
It's crazy. It literally is. You know, if humans have advanced,
If we have the formula, we can just use the formula too.
you know, look at spaceships, you know, just everything. If humans have advanced so much technologically in the past, not even
The
50 years,
I think I
right?
said factorial
So much, right?
factorial
That's so
formula.
much. If there's other universes,
Factorial?
Yeah, factorial formula. It's
there was life before us, you know? There
it's
has
5
been.
exclamation.
There have been
Hmm.
other entities alive for at least 300, 400 years. Think of how far they could have gotten. You know, people look at like aliens and spaceships and they're like, that's impossible, you know? How is it
Factorial?
But if you think about it, if we've advanced
You talk about
this much in
Fibonacci or factorial?
100 years, 30 years, think if someone
I'm
had
sorry, can I see that if you have it? I don't see a formula with Fibonacci and factorial.
maybe they could have traveled through dimensions, you know? Maybe they have invisibility around them. It's possible, you know? It makes you think, you know, like maybe we are
I mean, there are many algorithms to find factorial too. This guy is showing the fast Fibonacci algorithms.
that's what I'm saying. You know, we've only advanced so far in 100 years. They had so much more time. They're probably
So,
just looking around at us being like, okay.
This is a formula for to find
and
the
another
next
theory
one,
that
right?
kind of supports
Well, I was just
theory of the
using.
multiple dimensions and universes is
Yeah, this is pretty
they
much
say like
the program to find factorial
the
too.
Big Bang happened.
That's a lot of code.
So well, the thing is, they say the Big Bang happened and then it was created, right?
That's called
They
fast.
do not have any recollection or anything before, like how it happened, like what,
Yeah,
like
index
how,
1 is going to be 1.
like how it happened. You know,
After you
nobody
initialize
has any
those
info.
values, then you
Nobody
just,
knows, like how it happened.
for index
What,
2,
but
you
Right, that's why I was looking at the previous and pre-previous now, right?
Yeah, and then
Something
for
of that
any
energy,
Fibonacci
that
series,
mass,
you just add
has a
the
bang like that,
index
right?
minus 1 plus
multiple
Index
little
minus
bangs happen everywhere. So if we're part of one little bang, and there's different little bangs,
It's always like
think of
that.
how many universes there could be.
So 1, 2, 2, 3, 3, 4,
So the index value at 0 is 0,
5,
1 is 1, and
You
then
know, the theory is like that.
any index
Yeah,
value after
yeah,
that is
it's
going
the
to
theory
be
of the
some.
multiverse, you know.
6,
We can be part of
7. It's not always, right?
and
Index 7, value is 13.
Yeah, but for For the first, you just initialize for index 0 anyway.
Yeah, that's what I was thinking. We can, we have to initialize one of this, otherwise always 0, right? So that's why we need to fix this a little bit, right?
He would always ask himself,
If what
how far is the sun from us?
I equal to
Correct and question to ask is, why are we this far from the sun?
1,
And if you think about it,
because 0 is already plus 0 plus 0, right?
so
Equals to
that
1.
is the sun, okay?
We have to make it to change the value output. When it's 1,
Too hot, If it's over here, it's gonna be too cold.
you have to record the previous equals to 1,
To
right?
sustain our type of life. And who knows?
Yeah, previous has to be equals to 1,
The universe is out there.
right?
Such some some
When previous equals to 1, then start to store 1. And then store 0. So let's try this one.
Yeah. So would it be possible for the universe to be infinite?
Okay.
Also surrounded by other infinite universes? Because like infinite means never ending, right?
technically yes, because so we right now
There you go.
are really blessed.
So we get the answer, right?
With our technology is kind of advanced.
0, 1, 1, 2, 3, 5, 8, 13, right?
The stars in the universe.
So that's a
As time
Fibonacci.
progresses and the future comes.
Now we can start to read the text in, add the button in as normal,
And all those like
and change n to be the value that you read in.
so right now they're traveling away from us.
So what I'm going to do, I'm going to
Really fast. But not fast enough.
add the button.
Yeah, we still have like a good amount of years to
So I'm going to add a button called Fibonacci.
And physicists look up in the sky, it's gonna be all black. So they're gonna think the Earth is the only thing.
I mean, this is one way that it's pretty much my algorithms that I get it out. You can always find your own way with the formula, right?
It's a bit like, and like, maybe like,
Fibonacci button.
if you weren't free this technology years ago, oh dude, we'd probably be like, maybe pretty.
Let me make it under
All those people had like,
under factorial.
like technology. They'd be like, it's crazy, man.
Alright, so we get a factorial Fibonacci button. So the same thing. We just need to read it in. And
Who doesn't mind killing people?
then just surrounding with Fibonacci button dot set on click listener new view dot on click listener and add the method on click and move the whole code in there. This is a code that's already working, and just clean up a little bit. With the n, we were talking about how to read the n, right? Using this,
Any two-digit number, right?
pretty much
Two digits.
very similar to this.
With a 5 at the end.
Replace this.
65 squared. Just think of
We
it.
don't need
That's
this.
literally- alright, here's 75 squared.
And
I used to know.
that should do.
I don't remember right now.
Oh no, dude, I figured it out.
Alright, so now we technically can't get any sequence of Fibonacci, right?
15. Damn, hold up.
Let's just test
Give
with
me like a harder one.
9
That's easy.
and hit Fibonacci.
85, 8, 9, 7.
Alright, so we might want to look at what happens. It could be the same issue when I
Hold up.
click edit text, get to string
No, I'm not
in.
thinking about it. I'm trying to relax myself first. I've had a long day at school.
We have to see
Give me a
whatever
different
value
number
that we
after,
read
so you know
in.
I've not been thinking about it.
Alright, give me a different one.
95.
So I hit, let's see, factorial still work. Now Fibonacci. On click, edit text, get text to string input parse end. I want to make sure this is actually show what I'm looking for. What I'm gonna do, I'm gonna put a toast in there to see if it actually show 9. Okay.
I can do 2-digit squares. Alright, square 63.
So this is just the pop-up like toast box to show the contents of what I read in.
No, you gotta do it in your head. Yeah,
This is just the part that we want to debug our code. It's supposed to show toast, right? It's not even show it. So it looks like it's not even get in here. And I mean, the class is pretty much is class time.
Yeah, it's done.
So you can like pretty much we just cover the concept of Fibonacci for that one. You can just go back and finish. Okay, and I want you to start looking at 4.2. 4.2 pretty much the same concept, right? For loop again. Print out the first 100 odd numbers. Print out the first 100 even numbers. But this is a challenge one, draw the diamond shape.
Wow.
And you can review the video, it's going to show you. This is the challenge just like the Fibonacci one. Okay. Alright, so I'm going to fix this and I'm going to just upload that. I mean, it's live already, so you can watch that later.
4.2. Are we doing Android app or Java app?
Android, when you do Android, you get 20% extra credit. That's why I started showing you from Android.
We don't. For extra credit, we don't have to do both, right? If we just do Android, we can get extra credit.
Right.
Okay. This guy woke up. Thanks, Professor.
You're welcome.
Last night, I was like looking at like relativity and I was reading Stephen Hawking's thesis for his PhD, and I was going through some numbers, and I figured out this pattern, right, for squares. So Professor, give me any 2-digit number, right, with a 5 at the end.
1 second.
Okay.
So the reason is right here out. It's always create a new out every time I click. And then let's do the Fibonacci every time.
He can look. He can look at it.
Let me comment this one out first.
Don't support that. Don't support that.
Use the fraction mostly. Or if it's like something
Let me see if it's even getting here.
Seriously, I thought you were like probably 22 or 23. Why?
It's not even getting there. Oh, because I use factorial button here. That's why. It has to be Fibonacci button.
Professor, can you take a pen pretty please? With the cherry on top.
Let me undo this.
On the cage.
Man, that takes so long.
No, you can do it when you're money.
Alright, so this one should work.
You know what I'm trying to teach you. So I take it.
Just the name of the button is wrong.
And then for bigger numbers.
So let's change it to 9.
I'm a little slower at
I have a
it.
quick question.
Now,
Can you upload this on GitHub?
just use for
So now it's work, right? 8 plus 13 is 21.
Yeah, upload on
And
the
change
code on
the code
GitHub.
words like
Yeah.
Mexico or like Argentina or like.
All right, so now it works.
And then, like,
So just check out
or something.
this.
And then-
So I'm going to put a code on Git now.
One sentence and you get some words in my head.
Kind of.
I mean, for me, it kind of works. I don't know. Maybe I'm
Yeah. Met apps chair.
Did easy numbers.
So it should be on my GitHub account. And it's going to be under github.com/
So in this case,
Jesse 200.
or
So you should be able to see my apps now. It's there. All right.
so this one is 15 plus